I've been putting off making this video for months because honestly, what I'm about to tell you is disturbing, and I mean genuinely disturbing, in a way that keeps some of the smartest physicists on the planet up at night. And here's the thing. It's not some new discovery from last week or some controversial theory that might be wrong. We're talking about something Oppenheimer figured out back in the 1930s and 40s that we've spent the last 80 years trying not to think about. Too hard. Because when you really understand what he discovered, when you really sit with the implications, it changes everything. You thought you knew about stability and safety, and the basic reliability of the universe, and look, I get it. You're sitting there right now, probably thinking, come on, how bad could it be? We've had atomic physics for like a century now. We've moved on. We understand this stuff. Except, here's what most people don't know. The scientific community hasn't moved on. They've just gotten quieter about it. Because in the last few years, as our measurements have gotten more precise, as our particle accelerators have pushed deeper into the quantum realm, we keep finding evidence that Oppenheimer was right about something way more fundamental and way more terrifying than just the atomic bomb. And if this kind of stuff genuinely blows your mind, if you're the kind of person who wants to know what's really happening underneath the comfortable lies we tell ourselves about reality, then hit subscribe right now, because what I'm about to walk you through is going to change how you see literally everything around you. And I'm not exaggerating. I mean, every single thing you can touch or see or measure exists in a state that, according to the math, shouldn't even be stable. And Oppenheimer was the first person to really understand that, to really see it. And it scared him in a way that had nothing to do with bombs or politics and everything to do with the fundamental architecture of existence itself. So, here we go. Let me show you what's got modern physicists quietly freaking out, and why Oppenheimer's name keeps coming up in conversations that most of them would rather not be having. And, yeah, I know that sounds dramatic, but stick with me, because the actual physics here is way stranger and way more unsettling than any dramatic framing I could possibly give it. And it all starts with a question that sounds simple, but isn't what's actually holding matter together right now. And I mean, right this second. And why should we expect it to keep doing that? And before you say that's obvious, that's what the strong nuclear force does. Let me tell you that Oppenheimer discovered something about that force that suggests the answer is way less reassuring than you think. Because here's what they teach you in school, right? Atoms are stable. The forces balance out electrons, orbit the nucleus. Everything's in equilibrium. And that's why matter doesn't just spontaneously explode or collapse or transform into something else. And that makes sense. That's a reasonable thing to believe, because look around you. Your desk isn't exploding. Your phone isn't collapsing into a black hole. The air you're breathing isn't suddenly transmuting into something toxic. So clearly, matter is stable. Clearly, the forces that hold atoms together are reliable and strong. Except, here's the problem. And this is where Oppenheimer comes in, back in 1939, while he was at Berkeley years before, Los Alamos years before. The Manhattan Project. He published a paper with a student named George Volkoff about neutron stars, and what they discovered was that there's a limit to how much mass you can pack into a neutron star before the pressure becomes so intense that nothing, not even the nuclear force that holds neutrons together, can stop it from collapsing, and that limit turned out to be around 3 times the mass of our Sun. And at first, that seems like just an interesting astrophysics fact, like, okay, neutron stars have a weight limit. Cool, but here's what Oppenheimer realized, and what he followed up on in another paper that same year with Hartland Snyder. If you compress matter past a certain point, The forces that we think of as fundamental and unbreakable. The strong nuclear force, the electromagnetic force, the quantum pressure that keeps matter from collapsing, they all fail, not because they get weaker, but because the geometry of space-time itself changes in a way that makes them irrelevant. And when that happens, you don't get a bigger neutron star, you don't get some new exotic form of matter, you get a singularity, a point where the laws of physics as we understand them literally stop working. And Oppenheimer proved mathematically that this wasn't some weird edge case. This was inevitable. This was built into the structure of reality itself. And here's where it gets really disturbing, because what Oppenheimer showed was that matter only appears stable. Matter only seems solid and reliable because we're looking at it in a specific energy range, at a specific pressure, at a specific temperature. But change those conditions, push the system hard enough, and there's nothing inherent in the laws of physics that guarantees matter will stay matter. And now, fast forward to 2023 and 2024. And here's what's got modern physicists worried sick. We've gotten really good at measuring something called the Higgs field, which is basically the field that gives particles their mass. And when you measure the Higgs field carefully, when you look at its properties with precision, what you find is that it appears to be sitting in what's called a metastable state, which is physics speak for it looks stable, but it might not actually be. And if it's metastable, that means there could be a lower energy state that it could fall into. And if that happened, if the Higgs field suddenly shifted to that lower energy state, it would happen at the speed of light, spreading out in an expanding sphere. And everything in its path, every atom, every particle, would be restructured according to new physics and matter. As we know, it would cease to exist, and we wouldn't see it coming, because the bubble of destruction would be moving at light speed. And here's the connection. This is Oppenheimer's insight from 85 years ago, playing out on a cosmic scale. He showed that what we call stability is really just temporary equilibrium, that the universe is full of these tipping points, where the forces that hold things together can suddenly fail catastrophically. And the math says this is possible. The measurements suggest it might be likely, and there's nothing we can do about it except measure more carefully and hope we're wrong. So when you hear scientists talking carefully, nervously about vacuum decay, or false vacuum, or the metastability of the universe, this is what they're talking about. This is Oppenheimer's ghost haunting modern physics, because he was the first one to really see it, to really understand that the stability we take for granted is way more fragile than it appears. And now, let me walk you through what this actually means. Let me show you how to visualize what Oppenheimer saw, because this isn't abstract. This is happening right now, inside every atom of your body. So picture this. Imagine you're standing in a valley, okay? A nice, comfortable valley with steep hills on either side. And you're holding a ball, and the ball is sitting at the bottom of the valley, and it looks stable. It's not rolling anywhere. It's just sitting there, and you think, okay, this ball is at its lowest energy state. This is where it wants to be. Except now, imagine that someone tells you that actually, there's another valley on the other side of one of those hills. A deeper valley. A valley that represents lower energy. And if the ball could just get over that hill, it would roll down into that deeper valley and release a tremendous amount of energy as it fell. But the hill is high. The ball doesn't have enough energy to roll over it on its own, so it just sits there in your valley, looking stable, looking safe. And that's what the Higgs field is doing right now. It's sitting in a valley that appears to be the lowest energy state. But the math suggests there might be another valley, a true vacuum state. And if the field could tunnel through the barrier, if quantum mechanics allowed it to jump that barrier, then it would fall. And when it fell, it would release so much energy that the fundamental constants of physics would change, and matter would restructure, and everything would end, not dramatically, not with fire or explosion, but quietly, almost instantly, as the bubble of true vacuum expanded at light speed, rewriting the rules of physics as it went. And we wouldn't know it happened because we'd be erased before the information could reach our brains. And Oppenheimer understood this kind of instability back when most physicists still thought of the atom as a tiny solar system with predictable orbits. He saw through that. He saw the quantum tunneling. He saw the tipping points. He saw that nature is full of these metastable states that look permanent until suddenly they're not. And here's another way to think about it. Imagine you've got a pencil and you balance it perfectly on its point. Now, technically, that pencil is in equilibrium. All the forces balance the pencil isn't moving. But you know intuitively that this is not stable, that the tiniest vibration, the smallest air current, is going to make that pencil fall, and when it falls, it's not going to go back to balancing on its point, it's going to lie flat, because lying flat is the true lowest energy state. And balancing on the point was just a temporary metastable equilibrium. And that's what Oppenheimer realized about matter. That's what his equations showed him. Atoms look stable, electrons seem to orbit reliably. The nucleus appears solid, but these are all metastable states. These are all pencils balanced on their points. And we only think they're stable because we haven't pushed them hard enough yet. And when you push matter really hard, when you compress it to neutron star densities, or when you smash particles together at near light speed in accelerators, you find out that the stability was an illusion, that there are deeper states, lower energy configurations, and the transition between them can be violent and irreversible. And here's what really got to Oppenheimer. Here's what haunted him for the rest of his life. Once you see this, once you really understand that the stability of matter is contingent and temporary, you can't unsee it. You can't go back to thinking of the world as solid and reliable, because you know that every atom is sitting in a metastable state, that quantum mechanics allows transitions between states that aren't predictable, that the universe is fundamentally uncertain at its core, and that uncertainty extends all the way up from quantum fields to human existence. And while you're processing that, drop a comment and tell me what city or country you're watching from, because I'm genuinely curious where in the world people are who want to understand this kind of thing, and I love seeing how global this community is. And, okay, so now let me get to the most disturbing part, the part that connects Oppenheimer's theoretical insights to what he actually built. Because here's what happened. Oppenheimer spent the 1930s doing this beautiful, elegant theoretical work on stellar collapse and quantum mechanics and the limits of matter. And then World War II happened, and suddenly the US government wanted to know if you could turn Einstein's mass-energy equation into a weapon, and they needed someone who understood nuclear physics at the deepest level. And Oppenheimer got the job, and he moved to Los Alamos in 1942, and he assembled this incredible team of physicists, and they started calculating. And here's what they discovered: the exact same instability that Oppenheimer had identified in neutron stars. The exact same metastability that he'd seen in quantum fields. It was sitting right there in the uranium nucleus. If you could just split that nucleus, if you could push it past its tipping point, it would release energy not because you were adding energy, but because you were allowing it to fall to a lower energy state. And the amount of energy it would release was given by Einstein's equation, E equals mc squared. And when you do that calculation, when you figure out how much energy is locked up in the E mass of an atomic nucleus, you get a number that's terrifying. You get roughly 21 kilotons of TNT equivalent from about 140 pounds of uranium-235, and Oppenheimer knew this. He calculated it. He understood it better than almost anyone alive. And on July 16, 1945, at 5:29 and 45 seconds in the morning, in the New Mexico desert, near a place called Trinity Site, they tested it, and it worked. And Oppenheimer watched from a bunker 6 miles away. And according to everyone who was there, he went very quiet. And later he said he remembered a line from the Bhagavad Gita, a Hindu text he'd studied for years. Now I am become death, the destroyer of worlds. And people often quote that line, like it's about guilt, like it's about remorse. But if you read the context, if you understand what Oppenheimer actually believed, I think it's about something different. I think it's about recognition. Because what he saw in that explosion, what he understood in that moment, was that he hadn't invented anything. He hadn't created some new force. He had simply revealed what was already there. He had shown that matter, the stuff you're made of, the stuff that seems so solid and safe, is actually trapped energy, that the stability is temporary, that the forces holding it together are contingent, and that if you know how to push, if you understand the physics, you can make it fall. And when it falls, cities disappear. And on August 6, 1945, at 8:15 in the morning, local time, the bomb they called Little Boy detonated over Hiroshima, and somewhere between 70,000 and 140,000 people died, most of them instantly. And 3 days later, on August 9th, at 11:02 in the morning, another bomb called Fat Man detonated over Nagasaki, and another 70,000 died. And Oppenheimer had known these numbers. He had calculated the blast radius, the thermal pulse, the radiation exposure. He had known what would happen. And he had done it anyway. And afterwards he said, in some sort of crude sense, which no vulgarity, no humor, no overstatement can quite extinguish, the physicists have known sin. And this is a knowledge which they cannot lose. And what did he mean by sin? What was he confessing? I think he meant this. Once you know that matter is metastable, once you understand that the stability of the world is an illusion that can be shattered with the right knowledge, you become responsible for that knowledge you carry. The weight of it. And you can't pretend. You don't know. You can't go back to innocence. And here's what connects to modern physics. Here's why Oppenheimer's name keeps coming up in conversations about vacuum decay and Higgs field metastability and the fundamental stability of the universe. Because what we're discovering now, what the Large Hadron Collider and other experiments are showing us, is that Oppenheimer's insight was more general than even he realized. It's not just uranium nuclei that are metastable. It's not just neutron stars that can collapse. It might be everything. It might be the quantum fields themselves. The Higgs field that gives particles mass might be sitting in a false vacuum. And if there's a lower energy state, it could tunnel into. Then the entire universe is metastable. The entire universe is a pencil balanced on its point, and we're just waiting for the vibration that makes it fall. And we can't predict when that would happen. We can't prevent it. We can't even see it coming, because it would propagate at light speed, and our ability to measure and predict would be erased by the very thing we're trying to measure. And this is what scares physicists. This is why you see careful, worried papers being published with titles like Metastability of the Electroweak Vacuum. This is why some of the smartest people in the field are very quietly, very carefully trying to refine the measurements of the Higgs mass and the top quark mass, because those measurements determine whether we're in a stable vacuum or a metastable one. And right now, the data suggests metastable. And that means that everything you see, everything you are, everything that has ever existed is contingent, is temporary, is sitting in a valley that might not be the deepest valley. And Oppenheimer saw this pattern first. He saw that what we call stability is really just slow instability, that the universe is full of these tipping points, and that knowledge, once you have it, changes everything. And here's where it gets personal, because this isn't happening somewhere else. This isn't about distant stars or theoretical particles. This is about you. Right now, the atoms in your body, roughly 7 octillion of them. That's 7 billion atoms are all sitting in metastable states. The electrons aren't really orbiting. They're existing in probability clouds. And those clouds are solutions to quantum equations. And those solutions depend on the fundamental constants of nature. And if those constants changed, if the Higgs field shifted, if the vacuum decayed, every atom in your body would restructure. You wouldn't feel pain. You wouldn't have time to process it. You would simply stop being the pattern that is you and become something else. Some lower energy configuration of quantum fields that doesn't support life or consciousness or anything we'd recognize as matter. And Oppenheimer understood this vulnerability. He saw it in the nucleus of the atom, and he saw it in the fabric of space-time itself. And when he built the bomb, when he demonstrated that you could release the energy trapped in matter, what he was really showing was that the illusion of permanence can be shattered, that the world you think is solid is actually an incredibly complex balancing act of forces and fields, and that balancing act only works under very specific conditions, and those conditions aren't guaranteed. And here's what haunted him. After the war, Oppenheimer became an advocate for international control of atomic weapons. He testified, he gave speeches. He tried to warn people, and in 1954, the U.S. government held a hearing, and they stripped his security clearance. They humiliated him publicly, and one of the reasons they gave was that he'd had communist associations in the 30s. But everyone knew the real reason was that he'd become inconvenient, that he was asking uncomfortable questions about whether we should keep building bigger bombs, about whether the knowledge we'd gained was worth the price. And he died in 1967 from throat cancer. And by all accounts, he died still carrying that weight, still burdened by what he'd seen. Because once you see that matter is metastable, once you understand that the stability of the world is contingent, you can't look at anything. The same way a flower isn't just beautiful, it's a temporary organization of atoms that happen to be in a stable configuration. Right now, a city isn't just a collection of buildings, it's a vast, improbable assembly of matter that exists only because the quantum fields haven't shifted yet. And your own existence, your consciousness, your memories, your sense of self, all of it depends on the continued stability of physical law. And there's no guarantee that stability will continue. There's just the observation that it has continued so far, and we extrapolate, and we hope. And so when you see news articles about physicists measuring the Higgs field, when you hear about vacuum decay, or false vacuum, or metastability of the universe, this is the shadow of Oppenheimer's insight. This is his ghost in the machine, because he was the first one to really see it, to really understand that we're all living in a metastable state that could collapse at any moment for reasons we can't predict or control. And the fact that it hasn't collapsed yet isn't evidence of stability. It's just evidence that we've been lucky so far, and that luck might run out tomorrow or in a billion years, and we have no way of knowing. And here's the final twist, the thing that makes this even more disturbing. Oppenheimer showed that not only is matter metastable, but that intelligence creates vulnerability, because the more you understand about physics, the more you can manipulate it. And the more you can manipulate it, the more ways you find to push systems past their tipping points. We didn't create the instability in the uranium nucleus. It was always there, but we created the knowledge of how to trigger it. We created the bombs and the reactors and the technology that exploits that instability And now we're creating particle accelerators that probe higher and higher energies that push matter into more and more extreme states. And every time we do that, we're testing the stability of the vacuum we're seeing if we can find a way to trigger the collapse. And maybe we can't. Maybe the energies required are so high that no human technology will ever reach them. Or maybe we're one experiment away from finding the right conditions, the right energy, the right configuration that allows the Higgs field to tunnel through to the true vacuum. And if that happens, if we accidentally trigger it, then we'll have done to the universe what Oppenheimer did to Hiroshima. We'll have revealed the instability that was always there, and we'll have shattered the illusion of permanence in the most final way possible. And that's what keeps some physicists up at night. Not the knowledge that the vacuum might decay naturally, but the knowledge that we might be the ones who trigger it, that our curiosity, our drive to understand, might be the thing that pushes reality past its tipping point. And there's no way to know. There's no experiment you can run to prove it's safe, because the experiment that proves it's unsafe is the one that ends everything. And so we measure carefully, and we calculate, and we hope that the universe is more stable than our equations suggest, and we try not to think too hard about what Oppenheimer knew, that knowledge is dangerous, that understanding is a burden, and that some truths once learned cannot be unlearned. So next time you look at a solid object, a table, a wall, a mountain, remember what Oppenheimer discovered, that solidity is an illusion, that matter is energy temporarily organized into stable-looking patterns, and those patterns only persist because the quantum fields haven't found a lower energy state yet. And inside every atom, there's enough energy to power cities or erase them. And the only thing preventing that energy from releasing is a set of forces that we think we understand, but that Oppenheimer showed us are contingent, are breakable, are temporary. And the universe doesn't care about our comfort or our survival. The universe just follows its equations, and those equations allow for collapse. And we exist in the narrow window where collapse hasn't happened yet, and we call that window reality, and we forget how fragile it is until someone like Oppenheimer comes along and shows us the math, and proves that the ground we're standing on is less solid than we thought. And now, you know what? He knew, and you can't unknow it. And that's the real burden of understanding. That's what he meant when he said the physicists have known sin. It's not guilt, it's knowledge. Knowledge of fragility, knowledge of contingency, knowledge that everything you love, everything you are, could end not because of malice or tragedy, but because the quantum fields found a lower energy state. And what would you do with that knowledge? How would you live differently if you really believed that every moment is borrowed time, that stability is temporary, that the universe is metastable? And if you found this mind-bending, if this changed how you see reality even a little bit, then drop a like right now so I know this stuff resonates, and hit subscribe and turn on notifications, because I've got more Oppenheimer discoveries to explore, more physics that'll make you question everything you thought you knew about existence. And comment below. Tell me which aspect of Oppenheimer's work you want me to dive into next. His quantum mechanics, his work on black holes, his moral struggle after the bomb. Let me know what you want to understand. And thanks for watching. And remember, the next time you touch something solid, you're not touching matter. You're touching a metastable quantum field. And Oppenheimer proved it.